Right, in this video I'm going to talk about linear function. Right, linear function refer to fx equals to ax plus b. So for linear function, it's actually a straight line. It's a function which can be written as a y equals to mx plus c. So for example, if I give you fx to be x minus 2. Right, this is a linear function where it's x power 1. So you know that you have very familiar with sketching a linear function. So a straight line graph, which this represent your y-intercept, right? Y-intercept -2, right? To x-intercept, y will be 0, right? To find x-intercept, you know that fx can be written as y. So and if this is y equals to 0, so x minus 2 equals to 0. So x will be 2. So it will be intercept at 2. So we just need 2 points to sketch the graph of linear function here. Right, linear function. So this is the graph for fx equals to x minus 2, whereas the domain and the range is always negative infinity to infinity here. Means what? Every input of x, you put any value of x, there is a value of y. You put 3, you have 1. You put -4, you have -6. Any value of x, this function is defined. So means if you see the graph is continuous, right? Means everywhere, every point of x here, the object here will have an image on the y-axis here. So it's negative infinity to infinity. For the range also, the y, right? The y will have an object here, right? So means that it's negative infinity up to infinity as well, right? So this is a way you sketch a linear graph, right? So if you have fx to be negative of 2x plus 1. So you can easily sketch this graph by using the knowledge of y equals to mx plus c, straight line, right? So you look at the plus 1 here. So you know there is a y-intercept here, 1. So to find the x-intercept, of course you need to assume this to be y equals to negative 2x plus 1. So to find the x-intercept, it will be y equals to 0, right? This is the line where y equals to 0. This is the line, this is a y-axis is x equals to 0. So you want to intercept the x-axis, the y have to be 0. So it means negative 2x plus 1 have to be 0. So x have to be 1 over 2, right? 1 over 2. So you need the 2 point, then you can straight away sketching the graph here, right? The negative is show that the graph is decreasing, right? Decreasing. So now, what's the domain? The domain and the range will be the same for linear function, which will be negative infinity to infinity. All right. All right. In another continue from this video, I'm going to talk about linear function that have restrict domain. Right, let's continue with this example. A linear function with a restricted domain. Restricted domain means there is a range of x which for this function to exist. Alright, so this is the range or the domain. Right, from here is already given the domain here. Right, this is your domain. If they already given that the x is between what value? Alright, so you will know that the domain will be 4, include the 4, but exclude the 6, right? But it's actually, the graph is between the 4 and the 6. So at first you have to sketch the graph. You sketch the graph. So for example, x and y. So then you know that this is your y-intercept, right? This is your y-intercept. So you have 4, right? 4 as your y-intercept here. So because x equals to 0 is between these two. right? So then you know that they have 1, 2, 3, 4, 5, 6, 6, right? And here you have -1. All right. So I'm going to change this one to -4 so that you can see a bigger picture here. So you choose a -4. So if you say that between the x is between -4 and 6, it can be any value, right? It's a domain that restrict to a certain value. So -4 up to 6. So I'm going to sketch here with -1, -2, -3, -4, right? So I'm going to see what happened because this is a straight line, right? You know that you can sketch the graph. You can sketch the graph just by two points. So when x equals to -4, right? X equals to -4. So what is your y? Your y will be -½ x plus 4, right? Substitute the -4 here. You will have 2, 2, 4, right? 2, 2, 4. So negative, positive 2, 2 plus 4, you have 6. So means that 5, 6, 6. So means during -4, there's 0.6 here. So 0.6, I'm going to make this become a solid circle because of the equal sign here, right? Equal sign here. So when x equals to 6, you're using the boundary value here. So 6. So what's the value of y? So it will be -½ x plus 4. So you're putting the 6 inside here. 2, 3, 6, right? 2, 3, 6. You have -3 plus 4, right? So you have 1. So -3. So means during 6, you have 1 here. You have 1 here. I put an open circle because to tell you that not include the 6 here. So as you sketch the graph, they never intersect the X intercept. They not even intersect the X intercept. So you sketch the graph. This will be the graph, right? This will be the graph. I never draw until the end, right? Means after 6 there are no graph. Before -4 there are no graph. So that's why the domain will be in between these two. So of course the range is also restricted. Suppose the domain and range for linear function is always -infinity to infinity, but because of the restricted domain, the range also will be restricted. So if you look at the range, we look at the value of y. There are no graph here until so value of y 1 means starting from 1 but open, right? Up to, if you look at the maximum value here, after 6 there are no value, up to 6. So means up to 6 and include the value of 6 here. So this is the domain and range for this linear function. Alright, that's all for linear function graph.